Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. AWS Fargate brings the serverless philosophy to the world of containers. Traditionally, when running workloads in Amazon ECS or EKS, you had to provision and manage EC2 instances to host containers. This meant dealing with instance types, scaling groups, and patching responsibilities. With Fargate, all of that disappears. You define the container workload, specify CPU and memory, and AWS provisions the underlying infrastructure invisibly. Beginners should think of this like food delivery. You still choose the meal, your container image, but you don't worry about the kitchen staff or the ovens. Fargate ensures the meal is prepared and delivered without you managing the restaurant. Fargate supports both ECS and EKS, but the experience is slightly different. With ECS, you define tasks and services that Fargate runs without any host management. With EKS, Fargate schedules pods onto serverless infrastructure, letting you run Kubernetes workloads without worker nodes. The distinction is that ECS is AWS's native orchestrator, while EKS is Kubernetes compatible. Beginners can picture ECS as learning to drive an automatic car built by AWS, while EKS is driving a manual car but still letting AWS handle the engine underneath. Both approaches give flexibility, but ECS is often simpler to start. Task definitions in ECS and pod specifications in EKS remain the building blocks of Fargate. These templates define what images to run, how much CPU and memory each needs, environment variables, and networking details. Even though you don't manage EC2 hosts, the workload blueprint still matters. Beginners should see this like submitting a recipe card. The chef doesn't need you to buy groceries or appliances, but they do need to know exactly what ingredients and instructions you want followed. The task or pod definition is that instruction sheet for Fargate. One of Fargate's key strengths is the elimination of instance management. You don't scale by adding or removing EC2 servers. You scale by adding or removing tasks or pods. Each task is placed into AWS-managed compute capacity that expands elastically. Beginners should compare this to ride-hailing apps. You don't own a fleet of cars, but when demand spikes, more drivers appear automatically. Fargate ensures container capacity matches workload needs without customers worrying about servers. Networking in Fargate uses the AWS VPC mode, which assigns each task or pod its own elastic network interface. This gives containers unique IP addresses in the VPC and allows them to be secured individually with security groups. Beginners should imagine every shop in a mall having its own street address rather than sharing one entrance. This model improves isolation, simplifies security, and makes Fargate containers first-class citizens in the network, just like EC2 instances. IAM roles in Fargate come in two flavors: the task role and the execution role. The task role defines what permissions the containerized application has, such as reading from DynamoDB or writing to S3. The execution role is used by the ECS agent or Kubernetes to pull images and send logs. Beginners should think of this as employees having two sets of keys, one for their personal work, task role, and another for the building's utilities, execution role. This separation enforces least privilege and avoids unnecessary permissions leakage. Storage in Fargate is primarily ephemeral, meaning data written inside the task disappears once it stops. For persistence, containers can mount Amazon EFS file systems, enabling shared, durable storage across multiple tasks. Beginners should picture ephemeral storage as scratch paper on a desk. Fine for quick notes, but discarded when you leave. EFS, on the other hand, is like a shared filing cabinet that survives regardless of who comes and goes. This gives developers a choice between speed and durability. Health checks and container restarts are supported natively. ECS and EKS monitor container health, replacing tasks or pods that fail. This keeps services resilient without manual oversight. Beginners can think of this like a factory manager checking machines. If one stops working, it's removed and replaced quickly to keep the assembly line running. In Fargate, health enforcement is automated, ensuring uptime even when individual containers misbehave. Logs and observability are integrated through CloudWatch. Containers send standard output and error streams directly to CloudWatch logs, where they can be searched, stored, and monitored. Metrics like CPU and memory usage flow into CloudWatch metrics, enabling dashboards and alarms. Beginners should imagine flight recorders on airplanes. Every action and anomaly is logged, so investigators always know what happened. This visibility is vital for debugging and compliance in distributed environments. Amazon ECR, the Elastic Container Registry, complements Fargate by providing a secure place to store and scan container images. Images in ECR can be scanned for vulnerabilities, ensuring workloads are free from known issues before deployment. Beginners should picture this as a grocery store that inspects deliveries for expired goods before stocking them. With ECR, Fargate gets a trusted source of container images, reinforcing security in the deployment pipeline. Because tasks in Fargate run in AWS VPC mode, each ENI can be assigned its own security group. This allows granular control at the task level, restricting access on a per-container basis rather than per host. Beginners should think of this as giving each apartment in a building its own lock and alarm system, rather than securing only the main entrance. The per-task isolation enhances security and aligns with the principle of least privilege. Fargate's cost model is simple. You pay for vCPUs and memory provisioned, billed per second. Unlike EC2, there are no idle costs, and you don't pay for servers you aren't using. Beginners should compare this to renting power tools by the hour. You don't buy the tools or pay for storage. You simply pay for how long you use them. This makes Fargate predictable and efficient for workloads that scale dynamically or run intermittently. Typical use cases for Fargate include stateless web services, APIs and microservices, as well as batch processing and lightweight analytics. It fills the gap between Lambda, which suits short-lived, event-driven functions, and EC2, which provides total control over servers. Beginners should think of Fargate as a middle ground. Lambda is the bicycle for short trips. EC2 is the truck you own for heavy work, and Fargate is the rideshare that scales exactly when needed. It balances simplicity with container portability, making it a natural choice for many modern applications. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The decision to use Fargate, EC2, or Lambda depends on workload requirements. Fargate is best when you want containers without managing servers, balancing flexibility and simplicity. EC2 suits situations requiring full control over the operating system, specialized hardware, or custom networking. Lambda is ideal for short, event-driven code executions without persistent infrastructure. Beginners should imagine 3 tools in a workshop. EC2 is the heavy-duty workbench for full customization, Lambda is the quick hand tool for rapid tasks, and Fargate is the modular workstation that gives flexibility without the setup hassle. Choosing wisely ensures cost and performance align with business needs. Fargate excels with stateless services and scale-out patterns. Since tasks are independent, applications scale horizontally by adding more tasks rather than relying on individual containers to grow vertically. Web APIs, microservices, and ephemeral processing jobs all benefit from this elasticity. Beginners should think of stateless tasks as food orders at a cafeteria. Each tray is served independently, and scaling up simply means hiring more servers to hand out trays. By decoupling state from the containers, services achieve resilience and near-limitless scalability. Secrets management integrates seamlessly with Fargate. Credentials, API keys, and sensitive configurations should never be hard-coded into images. Instead, AWS Secrets Manager or Systems Manager Parameter Store inject secrets at runtime, accessible only by authorized tasks. Beginners should think of this as employees receiving secure envelopes each day with the codes they need, rather than taping passwords to their desks. This approach minimizes risk, simplifies rotation, and aligns with compliance expectations, making security a natural part of container operations. Deployment safety is another strength. ECS on Fargate supports blue/green deployments through code deploy, enabling new versions of services to run in parallel until validated. Once confirmed, traffic shifts to the updated version, minimizing risk. Beginners should picture this as building a new bridge right next to the old one. Once you've tested its strength, traffic is diverted, and the old bridge can be retired. Blue/green deployments keep services online while changes roll out, a critical pattern for production environments. Load balancing integrates natively with Fargate. Containers register as targets behind an application load balancer, enabling intelligent routing and health-based traffic distribution. ALBs can balance requests across multiple tasks, detect unhealthy containers, and support features like path-based routing. Beginners should think of this as assigning customers evenly across checkout lines at a store, while supervisors monitor each line and redirect customers if one cashier closes. This model keeps services responsive and fault-tolerant without manual intervention. For disaster recovery and global reach, Fargate tasks can be deployed in multiple regions. Route 53 can direct traffic using failover or latency-based policies, ensuring users connect to the nearest healthy region. Beginners should imagine a franchise restaurant chain. If one location closes, customers are automatically routed to the next closest branch. This design ensures resilience and performance while avoiding single points of failure in a global architecture. Fargate integrates with application autoscaling, allowing task counts to adjust dynamically based on metrics like CPU, memory, or queue depth. This provides the same elasticity familiar from autoscaling groups, but at the task level instead of instance level. Beginners should picture an orchestra adding or removing musicians depending on the size of the audience. The music remains the same, but the resources match demand perfectly. Autoscaling ensures applications stay efficient while maintaining performance. Observability in Fargate builds on familiar AWS services. Metrics flow to CloudWatch, logs capture container output, and traces can be enabled with X-ray to visualize request flows. Together, these tools provide full visibility into performance and bottlenecks. Beginners should imagine a car dashboard combined with a GPS tracker. You not only see current speed and fuel, but also trace the entire route taken. Observability ensures developers detect problems quickly and maintain confidence in distributed systems. Cost tuning in Fargate requires choosing the right vCPU and memory allocations. Over-provisioning wastes money, while under-provisioning causes throttling or failures. Unlike EC2, where idle servers are paid for continuously, Fargate costs accrue only for running tasks. Beginners should think of this as renting meeting rooms by the hour. You book the space you need, and when the meeting ends, costs stop. Careful right-sizing ensures workloads remain both performant and cost-efficient. Compliance and isolation are enhanced in Fargate since tasks run with kernel-level separation on AWS-managed infrastructure. This means noisy neighbors are less of a concern compared to running multiple customer containers on the same EC2 host. Beginners should picture this as having private office suites rather than cubicles in an open-plan space. Each tenant is walled off for safety, aligning with enterprise compliance frameworks and reducing shared responsibility risks. Still, Fargate has limits. Each task is bound by constraints on ENIs, image size, and the number of exposed ports. These limits reflect the managed nature of the service and can surprise teams accustomed to flexible EC2 hosts. Beginners should see this as renting a furnished apartment. You enjoy simplicity, but you can't knock down walls or add a new bathroom without moving to a bigger space. Knowing Fargate's boundaries avoids frustration and misarchitected designs. Common pitfalls include forgetting that storage is ephemeral, neglecting to externalize state, or underestimating the impact of E&I quotas on scaling. Teams sometimes misconfigure IAM roles, granting execution permissions too broadly. Beginners should view these as rookie mistakes in carpentry, using the wrong tool for the job, or failing to measure twice before cutting. The remedy is designing for statelessness, scoping permissions tightly, and testing scaling patterns under real load. From an exam perspective, Fargate is often described as serverless containers. If the scenario specifies containers without EC2 management or highlights a need for automatic scaling and per-task billing, the correct answer is Fargate. If the scenario calls for long-running servers with OS control, EC2 fits better. If the requirement is simple, event-driven code, Lambda is more appropriate. Recognizing this mapping ensures you choose the right compute option quickly. In conclusion, AWS Fargate offers a powerful way to simplify container operations while retaining portability and control. By abstracting away EC2 hosts, it provides elasticity, security, and cost efficiency at the task or pod level. Best practices include designing stateless services, using secrets injection, employing blue/green deployments, and right-sizing resources. For learners, the key takeaway is that Fargate bridges the gap between Lambda's serverless speed and EC2's full control. It is AWS's answer to modern container workloads that demand scalability without the weight of infrastructure management. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.